Hello Advent Coders, my name is David. I'm glad that you are back. We are going to do a practice run today with Advent of Code 2024. And we're gonna do 2022 day 4. Okay, so last video, and that's why I still have the same clothes on and everything. Last video I have that I've just done, I've just recorded. I've set up or showed you my setup that I've created for this year's challenge. And now I will go and do a practice challenge and take you along the journey. I'm not going to go for speed, but I am going to explain through what is going to happen in this challenge. So the first thing that I will always do on a new day is I'm going to say pi ARC pi 4, in this case 4 because it's the 4th day. And then I'm going to go up here and say, hey, I'm just going to read this while it's taking the input file. Now, I'm going to just, for this one, I'm going to read everything in details. Space needs to be cleared before the last supplies can be unloaded from the ship. So several elves have been assigned the job of clearing up sections for the camp. Every section has a unique ID number, and each elf is assigned a range of section IDs. However, as some of the elves compare their sections assignments with each other, they've noticed that many of the assignments overlap. You see the key things here are all highlighted, okay, to give you a time of what is important in this text, because there's a lot of fluff in it, obviously. To try to quickly find overlaps and reduce duplicated effort, the elves pair up and make a big list of sections assignments for each pair. Your puzzle input. Meanwhile, I will copy here the example because this is an example. For the first few pairs, this list means within the first pair of elves, the first elf was assigned sections 2 through 4. Sections 2, 3, and 4. This is key. That shows me it's inclusive. 2 through 4, essentially, not 2 to 4, because it's all inclusive. And the second elf was assigned sections 6 through 8, which is 6, 7, and 8. And so on. Okay, so it just gives me more examples. This example list uses single-digit section IDs to make it easy to draw. Your actual list might contain larger numbers. That is important because we don't want to just assume that we have single digits. That would be very small ranges and easy to do, but larger ranges might be a time more difficult. Why is this important? Because if we even talk about large ones like thousands, if we have thousands containing, we don't want to check, we don't want to do a brute force thing where we check every single section ID and see is that within the range of the other one. That would be insane. There's a bit of a better way to check for overlaps. But we see here, no overlap, partial overlap, full overlap, and partial overlap. Some of the pairs have noticed that one of the assignments fully contains the other. For example, okay, there's those examples. There's 2 such pairs in our example. And how many assignment pairs does what range fully contain the others? And then we have our puzzle input with our actual values, and it seems like there are 2 digits long usually. I don't see any that are 3 or more digits. So I guess theoretically you could check every single element. But it's still not the most efficient, for sure. We're going to do it a better way. Okay, so meanwhile, it has downloaded it with our input, so I don't need to worry about it. So I just go into main. I go to the very bottom, insert my example. I know the answer is supposed to be 2. And then I'm going to do a test run. And it's not all tests were not successful because I have a failed test over here. Exactly what we expect. So we set up our test. The test fails. Now we're going to go and make the test work, right? So what we want to do is return 2. Now the test succeeds, and now we want to refactor. Okay, so now we refactor and see why does this work, but I'm going to actually just take this out just to make it a tiny bit easier. So I know already I want to use this because it is a line-by-line basis. If you look at the input, you see each line I want to evaluate separately. Okay, and so each line has its own condition, and in each line there's 4 values. 2 segments separated by a comma, and then each segment is separated, like the beginning and the end values of those sections are separated by a dash. So it's 4 values, so we can go through each of those lines, and at the end of the line, we either increase t by 1 or we don't. And t in this case, and I can rename this, is full overlap. Okay, this might be helpful for readability, is that t is full overlap. So what are we going to do? We want those segment values. Okay, seg vals. Okay, the segment values. And I'm going to need to take the line and split it with comma. And that in that way, I'm getting each of the 2 segments. Okay, so if I now print this, then we will see that what's the short? I gotta go Shift F10. Okay, we see now that we are printing a list with those 2 segments. Now, I ideally want to again split now with a dash. So what I can actually do is I can say map, and I take this as the data, but I need now a mapping function. So I'm going to say split seg, split the segments, and I have def split seg with my segments. I don't need to do that here. I need a column though. And then I'm just going to return seg for now to make it easier. However, I want to make sure, because it's going to return me a list, because it's mapping through all of them, and it's giving me a mapping function that is for lazy evaluation. I've just learned that Python also does lazy evaluation, which is cool. And it's still giving me this back, which means the mapping is working because we're just returning the same thing. I could say just return 0. If we map now, we should get full zeros. Okay. I'm very sorry. I have a few dogs and they're just messing about a bit. But yeah, if I say no, just return 0, then it's mapping and giving me just zeros. Brilliant. So what am I doing? Each segment I want to split by a hyphen. And if I do this now, I now get to erase. Now, one last thing. It would be very helpful if this 2 was an integer, not a character or a string. So that is one last thing that I would like to do. So actually, I would need to map again. But this time, what I can do is I can use the lambda function, lambda x, and I'm going to say int x, and then I use this as my input. Now the map again returns a list. So I need to make sure I can actually return it as a tuple. I know I'm getting 2 values. Same actually up here. I can return it as a tuple. I hope that helps. Yeah, there we go. If it doesn't, I can always make it a list instead of a tuple. A set would be bad. A set would be really bad because in a set it would be the order doesn't matter anymore. But both in tuple and list, the order matters. So I'm just going to do this. So now, yes, amazing. We have now our segment values. So with this line and with these 2 lines, we have now fully parsed our data to what we need. And this is amazing. Let's actually say seg1, seg2. That should make this a tiny bit easier, I think. Yeah, and then I can actually compare those. In Python, do I do that by just indexing those? Yes! Okay, nice. So we have all of the values. Now, the logic for overlapping is actually really, really simple. If you look at the full overlap over here, we want to check one of them and see, and we need to do that both ways around, which is fine. I can probably just write a function so that I can just do the same thing in both directions. But let's say here, if the starting value of, in this case, the second one, if the first value is bigger than the or equal. My apologies, this time it was a phone call that I got. Okay, let's keep going. So yes, we are right here. So if the starting value of the one that we want to compare is bigger or equal, because in this case it would be equal in the end, then the starting value of the one that we think it contains, and if the end value is smaller or equal than the one we think it contains, then it is fully contained. In this case here, where it's an overlap, this only is true for one of those two cases. Okay? And the end value is also bigger in this case, so we know it's only partially contained. And with this information, we can actually... Oh, we can actually get interesting information. I'm trying to right now think. It's 4 comparisons. And with those 4 comparisons, we can make a couple of different statements. And I have the feeling, the way this is worded, I have the feeling that the second one is going to be about partial containments. If I remember right, because I did this one before. I think it's going to be about partial containments as well. So sometimes you can program with that in mind already. So let's go actually and say, I'm going to make a couple of bools I'm going to be creating, okay? Or, yes, I'm just going to say, and I'm going to call this A and B. Just so for my next here, A1 bigger than B1. Or I'm going to say A1 B1 equals A0 greater or equal than B0. Okay, now B1 A1. This is a really bad naming thing. But I'm just going to keep with it. So if A is bigger or B is bigger, then B... And the reason why I can't just do, oh, if this one is true, this one must be false, this is not necessarily true because of the greater equal sign. Because the other one, we only know that it's smaller, but we don't know if it is actually also smaller or equal. So we want to definitely do this. So now it's this way around, and now I do the exact same thing with the 2's. Really, this should be 0s. Right? So and now I'm going to say with these 1, 1, 1, 1, 1, 1, 1. And now we have all of the conditions already to make a statement about if it's a full overlap. So if if A0, B0, and so in this case it would be this way. If A is bigger than B, and if A0 is bigger than B0, and if B1 is bigger than A1, I think, or in this case I need to say, and not A1, B1. Then full overlap is plus equal. Full overlap plus equal 1. If, or, now this might also be the case the other way around, or, and in this case I need a bracket. So this is now if A is contained in B. Now I also want to do the other way around if B is contained in A. And not B1, A1. That should be correct, I think. So if I now, no, my solution is only 1. Okay, I clearly did it too complicated for myself. So I'm gonna simplify things. It is in principle that it is correct. I'm just thinking dumb about something. Does contain, and then we have the two values a and b. Okay. So now all I need to say is if does contain a comma b or does contain b comma a. If one of them contains the other, then it's a full overlap, and then I want to add +1. Now, does A contain B? And I could do this in a second. I could just change it easily, which is fine. But for now, full overlap would essentially just mean return A 0 greater than B 0. If A is contained in B, it would be greater or equal, as we can see in the graphic, right? So let's say this is A, it would be greater or equal to this. And then the n, which is the 1, would be smaller or equal this. So, and A1 is smaller or equal B1. And now it should work. Now it should work. Haha! And we see it works because it's now giving me a solution. It doesn't just say the test was successful, it's giving me a solution, and bada-bing, bada-boom, we have a gold star. Now we're going to the second part of the puzzle. Part 2. It seems like there are still quite a bit of duplicate work planned. Instead, the elves would like to know the number of pairs that overlap at all. Haha! So partial overlaps. Okay? Okay, so I'm just gonna call T2 par overlap. Okay, so we have a full overlap, we have a par overlap. Now, this is a partial overlap. Question is, can I also let's see. A partial overlap. For it to not be a partial... Oh! I'm sorry. You saw my face come repeating. For it to not be a partial overlap. Yes. Okay. The starting value needs to be bigger than the end value. And the end value, or the end value needs to be smaller than the start value. That's how we make something. Okay, does contain, does overlap. Okay, and we say A comma B. There's probably actually a better way to say it. So if A0 is greater, and it's important to say greater, not greater or equal, greater B1, the end of 1, or if B0 is smaller than A, no. No. If the beginning of A is greater than the end of B, if the end of A is smaller than the beginning of B, then it does not overlap. So in this case, we know no, it does not overlap, so I'm just going to say not. And that should do it. So if does overlap A comma B, or does overlap B comma A, then I'm going to say par overlap plus equals 1. And I know, and just to make sure that I get the test correct as well, the test says that we have 4 such values, so I'm going to replace this by 4. And if I get a solution again, then it got it correctly, and I can now put in the solution, and I get another gold star. And with that, we have completed day 4. So recap again what we have done over here. Okay, so we have I think the biggest thing is, how do we process our data to make it easier for us to work with it? We needed those individual numbers, and we needed to know which numbers belong to which part. It was already fairly nicely sorted in the input, which made it easier. So we could just we could split it by comma for each segment, and then we can take this split segment function to map each segment and give us a more usable version of it. And then in there, we split it by the dash, and we map each of those as integers so that we then can work with the numbers instead of just the strings. So A and B are literally just the two segments, segment 1 and segment 2, that have a start and an end value. Because we have start and end values, we don't have to go through every single element individually. We just have to look by starting and end positions and compare them to one another to see if they're either partially or fully overlapping. I do this with this function does contain, and I'm putting it in backwards so that it's checking first, okay, does this contain that? And then we're checking, oh, does this contain that? So that we're doing it both ways around. And those are each just really simple comparison functions that you need to cleverly think about it. So for the contain, it means that, yeah, the start is bigger than the start of the one that's containing, but the end is smaller than the end that it's containing. And that way it is inside of it, right? If one of them is outside of it, it would be the beginning would be smaller than, or the end would be bigger than, and that would not be correct. For the partial overlap, there's a lot more cases to it. But here it is easier to think about, okay, in which case does it not work? And the cases where it doesn't work is where the start is bigger than the end, or the end is smaller than the start. And that way they completely miss each other. If they did not completely miss each other, then there is some type of overlap. I hope this makes sense. If it doesn't, please let me know. If there's a better way to do this, please let me know. If any of this stuff I could have done a tiny bit tidier or whatnot. I want to grow. I want to learn. Please help me out if you have suggestions. Otherwise, I hope you enjoyed this practice. I may or may not do another practice. We'll see. But we'll see you in the next video, which is either a full Advent of Code video or another practice. We'll see. You have a good day. Bye.